Hi everyone, and welcome to the intro video for Chapter 3 Part 2. So in this video I'm just going to talk very quickly about what's coming in this set of two sections. So we are going to be starting our discussion, our kind of nitty-gritty discussion of what to do when you have two variables that you want to do analysis on. So this is just the tip of the iceberg, and we're only looking at some pretty specific scenarios. So I just want to talk to you a little bit about what those were. So first of all, section 3.4 is we're comparing two means. And so what this looks like is in this section we are going to have two variables. So every problem will have two variables. Right? Now the way that this is going to work is we are going to have a categorical variable, okay, and that categorical variable is going to break up into two options. So this one categorical variable will have two options, okay, so option A and option B. Now, I haven't said anything about means yet. This says comparing two means. Well, the second variable, so there's two variables. Number one is a categorical, breaks up in these two. Then what we're going to have is the second variable is a quantitative variable. So variable 2 is quantitative. And with a quantitative variable, of course, then comes a mean or average. And so the big thing that we're going to be doing then is saying, okay, I have a sample. Well, I can split that sample up based on this first variable that's categorical. Some people will be in group A and some will be in group B. If you need to hold on to something here, you can just pick any categorical variable you want that splits people into just two groups. So the way we've kind of been doing things, you could do, if we're in the Berenstein Park, right? There were male and female bears. We broke up the bears into the two groups, right? So then the questions we'll have, so let me write that out just so you can remember it. Male and female, and this was, you could just remember the bears. This is the bear example. So if you want something to hold on to. We have a categorical variable that splits the bears into two groups. And then we will often want to know, is the average something for the male group, is that equal to the average something for the female group? Or maybe we think the average for the male group is different than the average for the female group, or bigger than or less than. That's the way that this first section is going to go. We're going to have two variables, one that's categorical, that you think of it as using it to kind of break up your two groups. And then for each group, you bring in the second variable that's measuring something about them. It could be weight. So again, in this case, mu, if you want to think of something, maybe mu here, mu m could be, wow, that looks like mu. That was a bad choice. M was a bad choice. But this is mu for the male. We can just write male here. That's easier. Maybe this could be the average weight of the male bears. And so then we could compare that, try to learn about that compared to the female bears. Okay? If you want a different example, we could think of instead, okay, I am going to take a bunch of people, we're going to test a drug. So how does that work? Well, in group A, I'm going to say you have the drug. Group B, you don't have the drug. That's categorical. Yes drug, no drug. That's two groups I put them in. Then I'm going to measure variable number 2 on each of those people. What you measure, well, maybe it's average number of headaches that they get per week. So, how many headaches are you getting per week? That's quantitative. I want to know if there's a difference between the people with the drug and without. in terms of the number of headaches they're getting? That's the type of question we're going to answer in section 3.4. So again, I start by breaking up using a categorical variable into groups, and then I try to measure. Now you might say, well, Mr. B, this seems great, but what if I have 3 groups? What if my categorical variable breaks up into 3 groups? Like, what if I want to do a lot of drugs give a lot of drugs in group A. Group B could be give some drugs, and group C would be no drugs. That's a reasonable thing to want to do. Well, we can't quite apply just comparing 2 means to that. We need something a little bit more to actually do an analysis there. It's not too much more. It still uses hypothesis testing and p-values, all that stuff we've learned. But there are a few little differences. So we're not going to get to that in this course. We just don't have enough time. But you will see that if you take another statistics course. And it's really not something that's beyond what you can do after you finish this class. You can just pick up that next step. It's just a different statistic. You don't just compare 2 things. You're comparing multiple, and you got to think about how you can make one parameter, like a mu or a difference in mu's. How can you make one thing that describes maybe multiple variables or categories? That's not for us, but is something that you'll definitely see going forward. Very useful. So that's what we're going to do in 3.4. In 3.5, on the other hand, what we're going to be doing is we're going to be comparing 2 proportions. And so the setup of this actually looks pretty similar. You're again going to start, you're always going to have 2 variables. Okay, yeah, 2 variables. And so what you're going to do is you're going to start off with these variables. You're going to say, okay, I'm going to have a categorical. And again, it's going to be the same setup. So I take this categorical and I say, okay, that gives me 2 groups to split up into. But then the second variable that I'm going to actually do a measurement on each group now to try to learn about, understand, that's also categorical. So just both variables end up being categorical here. And so you're going to be asking questions like, the proportion of something for the people in this group, is that equal to this group? Maybe you think it's different than this group. Or maybe you think, we could go one-sided, that the proportion for A is bigger than B, or less than. So all of these being possible options for your hypotheses. But that's what they're going to look like. Instead of comparing a single pi to a number, like 0.5 or 0.75, we'll be asking the question, do the proportions in these groups differ, or are they the same? And that'll be our question now. And what you'll see is we're going to have to talk a little bit about how we simulate here, right? I'm not giving you like pi equals 0.5. Oh, that's a coin flip. I can simulate that. That's not there, right? I don't see that. So it might not be obvious how we actually do a simulation here. But we'll go over that together, and we'll use that. Plus also, we'll talk about how you can use theory, just like we did in section 3.3, to predict some of what the simulation can do. And so you could use the theory-based approach in the applets to do your hypothesis testing, your p-values, all that stuff as well, with formulas. So we'll talk about both those things, but it's pretty nice. Once you get the setup and you get a feel for how the hypotheses go, then you just start going. And all the things you've learned so far, they still all apply in terms of p-values and claims and conclusions and all that stuff. Hypothesis testing and hypotheses, all that's still there. It's just we're adding 2 variables now and thinking about how to compare them. That's it, though. That's the 2 sections. I've got a categorical variable that breaks up into 2 categories, and I'm going to, in section 3.4, my next variable is going to be quantitative on each of these. I'll be comparing some kind of mean between the groups. That's 3.4. If instead I want to compare not a mean between each group, but a proportion, a percent, right, then I'm going to go this way. Okay, so this second categorical variable gets me here. But again, you could ask, well, what if my first categorical variable, breaks up into more than just two groups? And we're not going to be able to get to that, cover that, but there are, of course, methods that you can apply that will get you there, get you p-values, get you where you want to go. So something, if you take another course, then you'll have a chance to see that and apply it, but the foundational things are all the same. Set up hypotheses, get a statistic, use an applet, use theory, use simulation to figure out if your statistic's usual, unusual, make a conclusion about the hypotheses. It's all the same. So we're scratching the surface a little bit on how to do multiple variables, but this goes quite a bit deeper in all the different ways you can do this depending on your scenario. But for us, our categorical variables will have two options, and for both of these, that's the setup first. Categorical variable into two groups, and then am I then bringing in a second categorical variable, that's 3, 5, or am I bringing in a quantitative variable, that's 3, 4.